2 anchors, 30,000 pounds each, and neither one is actually what holds the ship in place. The USS Gerald R. Ford weighs over 100,000 tons. It is 1,092 feet long. Its flight deck alone covers 5 full acres. And when the ship needs to stop, the system it uses is so extreme, so brutally engineered, that most people have no idea it even exists. The anchor on a US aircraft carrier is not the story, the chain is. And once you understand what that chain actually is, how much it weighs, what it does, and what happens to sailors who get too close to it, you will never look at one of these ships the same way again. Most people picture an anchor the way they see it on a Navy tattoo. Simple hook, drop it, ship stops, done. That is not how it works, not even close. On an aircraft carrier, the anchor is just the beginning of the system. The real engineering, the real story, is everything connected to it. And it starts with a number that will stop you cold. If you think the men and women maintaining the system deserve more recognition than they get, type yes in the comments right now. These sailors work with equipment that most people can't even picture. The anchor itself, bigger than you think. Every Nimitz-class carrier in the U.S. Navy carries 2 anchors. Each one weighs 60,000 pounds. That is 30 tons per anchor. To put that in perspective, a fully loaded semi-truck weighs about 40,000 pounds. One aircraft carrier anchor outweighs it by 20,000 pounds. The anchor used on U.S. carriers follows the Navy's stockless design. It has large pivoting flukes, the flat blades at the bottom that dig into the ocean floor when deployed. The design works in almost any seabed condition: sand, mud, rock, soft sediment. Whatever the ocean floor is made of, those flukes find a grip. Now here's the part that surprises almost everyone. The anchor alone cannot hold the ship, not even close. 100,000 tons of steel, sitting in open water, exposed to wind, current, and wave, requires far more than a 60,000 pound hook in the sand. So what actually does the job? The chain, the real star of the system. The anchor chain. And this is where the numbers become genuinely insane. On a Nimitz-class carrier, the chain is 1,080 feet long. On the USS Gerald R. Ford, it stretches 1,440 feet. That is longer than 4 football fields laid end to end. Each individual link of chain on a Nimitz-class carrier weighs 350 to 360 pounds. On the Gerald R. Ford, engineers used a newer, higher strength steel that brought the individual link weight down to 136 pounds. A significant engineering achievement. But here is where it gets staggering. The chain is divided into sections called shots. Each shot is 90 feet long and contains 57 individual links. A Nimitz-class carrier carries 24 shots total, 12 shots per anchor. When you add up the weight of both anchors and all 24 shots of chain on the Nimitz-class carrier, the total comes to 366,000 pounds, 183 tons, just in anchors and chains. That combined weight, sitting on the ocean floor in long curved line, is what actually holds the ship. The anchor bites into the seabed. The chain lies along the bottom, and its sheer mass resists the pull of wind and current. When a wave pushes the ship, the chain absorbs the shock like a massive spring. It stretches taut, then falls back. The weight of the chain itself pulls the ship back into position. The anchor is the anchor point. The chain is the anchor system. How the chain is deployed and why it is dangerous. Dropping anchor on an aircraft carrier is not like dropping anchor on a fishing boat. The entire system sits at the front of the ship. The forecastle, also called the forecastle, this is where the anchor windlass lives. A windlass is a massive powered winch that controls the chain. On a carrier, it is driven by a heavy-duty hydraulic or electric motor, powerful enough to raise and lower hundreds of thousands of pounds of steel. When the order comes to drop anchor, the crew on the forecastle releases the chain stoppers, the mechanical clamps holding the chain in place. Then, with a roar that shakes the entire bow of the ship, the anchor drops free, and the chain runs out through the hawse pipe. a reinforced steel tube built into the hull at a controlled speed. Here's what almost no civilian ever hears about. That chain running out at speed is one of the most dangerous things on the ship. A single link weighs between 136 and 360 pounds. When the chain is running, those links are moving fast, whipping through the hose pipe, piling into the water below. If a link snaps under the tension, and it has happened, the broken piece becomes a projectile, a 360-pound piece of steel, moving fast enough to kill anyone in its path. Sailors assigned to anchor detail stand clear of the chain run. There are hard painted safety zones on the forecastle deck. Nobody stands inside them when the chain is moving. Nobody. Once the anchor is on the bottom, the ship backs down slowly, reversing the engines just enough to drag the anchor flukes into the seabed and set them firmly. Then the crew monitors chain tension continuously. If the ship starts to drag anchor, meaning the anchor is sliding along the bottom instead of holding, they know it within minutes. The 5 to 7 rule, why so much chain goes out. Here's something that surprises people when they first learn it. When a carrier drops anchor in 100 feet of water, the crew does not let out 100 feet of chain. They let out 500 to 700 feet. This is called the scope ratio. 5 to 1 or 7 to 1. 5 to 7 feet of chain for every 1 foot of water depth. The reason is physics. If the chain goes straight down from the bow to the anchor, it pulls the anchor upward, reducing the grip of the flukes on the seabed. But when 5 to 7 times more chain is deployed, the chain lies flat along the ocean floor first. Before rising to the ship, that flat section means the force on the anchor is almost perfectly horizontal, which is exactly the direction the flukes are designed to resist. The longer the horizontal run of chain on the bottom, the stronger the hold. The heavier the chain, the more it resists being lifted by movement above. This is why the chain weight matters so much. It is not just connecting the anchor to the ship. It is doing active work, absorbing energy, damping motion, and keeping 100,000 tons of warship from drifting into something it should not hit. The Gerald R. Ford upgrade, lighter, stronger, smarter. The USS Gerald R. Ford, America's newest carrier, introduced a redesigned anchor system. The anchor itself was reduced from 60,000 pounds to 30,000 pounds, half the weight of the Nimitz-class anchor. The chain links were redesigned using higher strength steel alloys, bringing individual link weight down from 350 pounds to 136 pounds. The total chain length was increased from 1,080 feet to 1,440 feet. Engineers at Huntington Ingalls Industries conducted load tests with simulated drops of 180 feet and 360 feet to verify the windlass systems could handle the forces involved. The result is lighter overall system. That still provides the same holding power because holding power is about geometry and scope, not just raw mass. This is what American military engineering looks like. Not just building bigger, but building smarter, finding ways to reduce weight and complexity while maintaining or improving capability. What happens when it goes wrong? Here's a question worth sitting with. What happens if a carrier drops anchor while still moving? The answer is nothing good. An aircraft carrier moving at speed, carrier momentum that is almost impossible to comprehend, 100,000 tons moving at even a few knots represents an energy load that the anchor system was never designed to absorb all at once. If the anchor is dropped while the ship is underway at any significant speed, the chain would take the full force of that momentum. The links could fail under the tension. The hose pipe, that reinforced steel tube in the hull, could be damaged. In the worst case, the chain locker itself could suffer structural damage, compromising the ship's watertight integrity in the bow. This is why anchor operations on a carrier are slow, deliberate, and carefully coordinated. The ship is brought into a near stop first. The crew is positioned and ready. The windlass is set to control the rate of descent. Nothing happens fast. Everything happens by procedure. The sailors who do this job train for months before they are trusted with an anchor detail. And even then, they do it under the supervision of experienced petty officers who have watched the chain run dozens of times before. The bigger picture, what the anchor says about the Navy. Think about what the system represents. 2 anchors, 60,000 pounds each on the Nimitz class, 1,080 feet of chain per anchor, 350 pounds per link, 183 tons of steel. just in anchors and chains. And that entire system is built for one purpose: to give a crew of 5,000 sailors a safe place to stop. Not to fight, not to protect power, not to launch aircraft, just to stop safely. The anchor system is the quietest part of the most powerful warship on Earth. It does not get news coverage. It does not get named in speeches. The sailors who maintain it work in dark, flooded, confined spaces, doing physically brutal work that the rest of the ship never sees. And they do it because without it, the most capable naval vessels in history cannot safely come to rest. That is the kind of thing America builds. That is the kind of sailor America trains. And that is why the U.S. Navy remains the most powerful maritime force on the planet. Outro. 2 anchors, 183 tons of chain and steel, 4 football fields of links lying on the ocean floor, and a crew of sailors who maintain every single inch of it. That is what actually takes to stop a U.S. aircraft carrier. If this gave you something worth knowing, hit that like button and subscribe so you never miss what we cover next. The next video goes even deeper into the systems and the people that keep America's Navy ahead of everyone else on Earth.